Welcome back, boys and girls. Last time I did basically, honestly, a job explaining all the systems that were going on in my project. So I want to tackle it a little bit different, and I'm going to take each video to explain each system that I'm actually also currently developing. And this way you get a better insight on how everything is working, and I actually can explain. I took a lot of notes also. It's not a script, but I needed a lot of notes because if not, I would lose myself also explaining because I'm kind of terrible at it, to be honest. So today I want to start with a really good one, saving and loading. I also mentioned in my previous video that I want to somewhat finalize the character creator that I'm working on, using also the dainty modular characters, the sidekick characters, which is beautiful. And I wanted to finalize that system so I could test it out with a real scenario. So in this case, I'm saving the different body parts that the player chooses. And we're saving that into a file, and whenever the game loads up, if there are body parts saved, then we can load the character with those specific parts. But enough talking, let me show you actually what I have going on in the engine for the character creator so far. As you can see, I improved a little bit of the overall graphics. We have different tabs in here, and it's still not possible to change the body shape. I still haven't developed that part. I created a custom slider where I can actually choose the icon for the dragger, because I was having this issue in Godot. If I use just the regular slider that Godot has out of the box, it just doesn't work. If I change the texture, I cannot change its size. So if this picture is 500 pixels, I will get a dragger that it's just huge and I cannot change it. So I somewhat extended that slider, and I basically added a texture rect attached to that slider, and I'm changing its position and calculating. So this is 0, this is 1. So I'm actually doing those calculations. So when I set up the blend shapes, everything is already correct. And I get a really nice custom slider where I can set up the dragger. Basically everything behind it, it's working the same as the slider. There is just the background and the fill. And when you set the value, you iterate over that. So this will be our next goal, is to have this working, save that data, and also the colors. It's still not possible to change the colors. I really wanted to work on change the body parts and save the body parts so I could really have that locked in. So as you can see, I also changed the icons. Now we get actually a thumbnail for the part that we're choosing, which is actually way nicer than just having a text saying ear 1, ear 2, body 2, or whatever. Like, it's way nicer, more visual for the player, so it gives it a nicer touch. Yeah, I really enjoyed it. So as you can see, for the hairstyles, for the beards, all the outfit that is possible to choose. And I also added these 2 buttons just so I can actually, the cancel doesn't work yet. I only tested out the save because I wanted to save the data. So baby steps. Slowly I will start explaining how this whole system works. I started with the singleton, and this singleton is basically in charge of reading off and saving to our save file. It basically grabs that data and writes it to the file, and then we can access that same file to grab that saved data. Just like the Godot documentation mentions, I'm using basically the same technique. I'm just not saving the nodes to a persistent group like they do it in here. I'm not using the group part. I'm using my interface for that and the singleton. And I'm using basically the same method. The only difference is that in here they write it to a JSON file. And at least in this example, there is no type of encryption, no nothing. So this will save it to a human readable file, which makes that so if a person opens that file in Notepad++, for example, they can basically read all the data. They will read the player HP and they will say 100, like, let's put it to 1000, why not? And then the game will just load that data. If you don't protect in this case, when you're loading the data for it, it will still be easier to cheat. So I'm using what they call binary serialization, and the difference is that it's not completely encrypted, but at least it hides a lot of the data. I'm gonna show you later on how is it working, but the only difference is that I'm saving my overall dictionary with store var. This will save it to a binary and will make the file not completely unreadable, because I already tested it out and it still leaks if I'm saving a string, for example. There is still leaks where you can read a whole string, so you could still change a path to a body part, for example, but it still protects like 80% of it. It's just like a small extra layer of protection. So I'm kind of on this idea that you need to do it by layers. So I can add this, then I can add extra encryption, and then I can make it the hardest possible, at least in my reach, for the player not to cheat on the save file. So back to our singleton. I'm going to try to make it more visual. Like, I'm going to try to make a pretty edit over here so you can actually understand how the data is being saved. This singleton holds a big dictionary. This dictionary will be populated with all the other data that is required for each node. So in our case, we'll have our player visuals dictionary stored inside of the big dictionary. And then inside of our player visuals, we can have more data. So I will have another dictionary with the character body parts. And this will basically work the same for every node. So inside our player visuals, I can have also the data for player colors, player blend shapes. And we can store these dictionaries inside of one unique dictionary that will be stored inside of even the bigger dictionary that is the global one. So in this case, each node will grab only the specific key that it needs. And then from that key, we can spread the data however we want. So now let's talk about grabbing the data, the actual data that you need to save to the save file. I created a new class and I called it save interface. It's not the typical interface that you know from C# or C++, but I call it interface because it's the middleman between the node that you want to save or load the data to, and it's the middleman between that node and the singleton that holds the global save data. And this node requires you to set some specific settings. So our main one will be our save data key, as you can see in here, player visuals. And if you go back to the chart that I was showing, you can see that player visuals will be our unique ID on that global file. And also, I call it unique ID because it really needs to be unique. So if you put it visually, if you have two nodes with saving to the same key, you can already see how the data will be overridden when you're saving your data. You can only have one unique ID per scene. You can also have a different, like the same interface on a different scene, but as long as you don't have like two save interfaces with the same unique ID running at the same time, there will be no problem. You can set this to whatever name you want to set. But also to prevent that, I also added a few checks in the ready function. So if it doesn't have this, like if it's not set up, or if it has like another data key running at the same time, it will trigger a warning, and you can see it in the console that it will trigger like saying, hey, is already in use by another node, so the data will not be saved. And the way I do this is basically when the save interface loads, I'm adding the save interface to an array on the singleton, and I'm registering basically like as active. When the save interface on exit, I will clear it from the array, and if a double is found, if a double is found on the array, it will trigger this warning and it will not save the second save interface with the same ID. And also this array is really useful because when the player saves the game or an autosave comes in, like the singleton will go through each node that it's instanced, and it will create another dictionary using that unique ID that I talked about, and it will save that data to the global dictionary, which will then be saved to the save file. And now you ask, but how does the save interface grabs the data from the node that you want, right? Because the save interface doesn't know anything about what do you want to save. So for this, on the save interface, you also need to set up what I call the data sorter. This data sorter is basically the node that holds whatever variables that you want to save. So in my case, my data sorter is the player one visuals node, which contains all the variables, body parts, colors, blend shapes, as you can see. And after this data sorter, you also need to tell the interface like, hey, what do you want to save? Which variables do you want me to grab from this data sorter node so that I can send to the singleton so that it can be saved to the file? And this basically, you just need to set up these variables as exactly they are called in your data sorter node. So if I go to my player visuals, you can see that on the top, I have some default settings, but they are called exactly the same. Visuals data, I want to save visuals data, colors data, and so on. When the game is being saved, the interface will then go through all the variables in this array, and it will ask the data sorter like, hey, what is this value? And let me save it to a new dictionary, and then it will return this dictionary to the singleton. And then the singleton can handle all the rest. Now loading the data. How does loading work? Basically, I also added a warning for this. Our data sorter node will need to implement a method that it's called onSaveDataLoaded. Yeah, exactly. onSaveDataLoaded. If this method is not implemented, it will also throw a warning, say, hey, you need to implement this so you can actually load some data. So let's say we start the game, we boot up the game. It will first search for if the save file exists, if it exists any save file. If it exists, it will then get that dictionary that it's inside of the file. If not, it will just leave the dictionary blank and it will return a blank dictionary. So when you're loading the data, you can also check if the dictionary is empty, then you'll need to load some default data. And I also added signals. I'm still not using the started loading data, but this can be useful also to trigger like the autosave, for example. And this basically emits when starting to load the data and also when finishing loading the data. And this finishing loading the data, it's actually useful because we need to wait for the file to finish loading before we try to get any value at all. And this finish loading data signal will be emitted to all the save interfaces that are instanced, so they know that they can start loading some data. And you can see when that signal is emitted, we basically just load the data from the global, which basically is just retrieving and calling the method that I set up on the singleton, which is get current loaded data by key. And we just pass our save data key, which is our unique ID for this interface. So this will return a dictionary, which is basically the saved dictionary containing the visuals data, colors data, and our blend shapes data. After loading that, we can just emit the signal to our data sorter and we pass the dictionary containing that data. Also on the ready for the save interface. So let's say, for example, that a save interface loads in before the singleton reads the whole file, or the other way around. Like the data is already loaded, like it doesn't emit any signal, and then we bring in a new save interface. How does that interface know? So on the ready, I also check on the singleton if the data is already loaded. If not, then we can await for the signal, which will then trigger down the normal loading. And if not, then we can move directly to the load data from global. Like if the data is already loaded, then we can move into the loading data part immediately. So when our node knows that he received the data, so when he receives the signal, the onSaveDataLoaded, we can check if the data is empty, then just load the defaults. But if not, we can load the player visuals. We can then choose whatever we want to do with our data. So we know that we are receiving a dictionary with the variables that we want, and then we can just, in my case, I can repopulate my dictionaries with that information. So I can change my current visuals data with the saved visuals data, and so on and so on. So if I go to the user data folder, you can see that there is no save file in here. But if I go to my game, and you can also see that the current body parts of the character are these. When you load up the game, these are the default ones, like it'll be kind of nude and kind of a blank template so that the player can customize. Let me just customize the character a little bit so you can see the system actually working. And let's put it some braces, lower left, yes. Some nice gloves, some big boy bands. And that's it, let's switch the shoes, okay. And if I press save, There is no pretty animation so far, but it's working. If I press save, and you can remember how the character is, if I press save and I close the game, if I go again to our open user data folder, you can see that I have a save file. If I open this with Notepad++, you can see what I was saying of the leaks. So you can still, no, never. So you can still see that some of the data, it's still being leaked. So for example, you can see that I get a bunch of nulls and STX in here, but I can still see that I'm saving a game manager, which is another node that has a save interface. I'm saving the player visuals data. And in here, you can also see that we have some complete leaked paths to, in this case, the body parts. So if still the player wants, he could still change these and, let's say, make a monster of the character with just custom body parts as he pleases. So that's why I will still have to add an additional extra layer of protection, and probably I will do that with encryption, but I still need to have a better look on that because there are a lot of opinions on encryption. So I still need to check what's the best scenario for my game. You can see if we load up the game in here, and sorry, I need to go through the splash screen. I'm not bragging, it's just because if I don't go through the splash screen, the save file is not loading. And you can see that our character was saved. If I go back to customize, and you can see that the parts that we chose are still the same ones. So our data was saved. So to really show it out to you guys, if I go here and I delete the save file completely, and if I reload the game, you see that no longer, and we get the default parts. Well, basically you got the blank dictionary, so we say, okay, let's load the default parts then. And I think I'm planning on releasing this as a tool for everyone that wants to use it. But I don't know, let me know what you think. Do you have some improvement points that you think that I should tackle? I don't know, let me know. Let me know what you think. And as I mentioned, I also know that every game is a different scenario, so this system might not even be applicable to you or even the best case for your game. But still, like, if you feel that it's a nice system and you want to use it, then go for it, why not? And that's all for this one. Let me know what you think. If you want any other videos explaining whatever other system that you saw in my project so far that you would like me to explain, let me know. I'm also working on that. I'm kind of going with the flow with the channel right now, so whatever I feel like explaining, I will explain. And that's basically it. Leave a like only if you liked it, and don't forget to punch that juicy subscribe and bell button, please. Have a nice one. See y'all later.